to give you my personal opinion, there's a lot of infrastructure management tools out there. I actually have quite a bit of experience in a lot of them. My personal choice is actually Puppet, so I hate to say that when I'm giving a presentation on Chef. When it really comes down to it, the difference between the two is they're very distinct in certain areas, but the reason why I would say a lot of people are going to pick Chef over Puppet these days is that Chef has really had a lot of time to mature. And number two, I would say the biggest reason that you can actually write real Ruby code inside of your Chef recipes. Whereas on the Puppet side of the house, you only have the Puppet, which the Puppet code, which is Ruby-like syntax, but it's not true Ruby itself. So one of the many reasons why I actually prefer Chef these days. So at a starting point, all businesses require change, and most businesses already have implemented Git or some other type of repository. Most good businesses are already going to have backups. And if we look at this list here, although it may look like I listed knowledgeable developers and engineers at the bottom, I would actually consider that the most important thing. I would consider it the foundation on which everything else is built. Because even if you have a backup system and a repository, without some people that understand it and know how to use it properly, it's not really going to offer you any help at all. It's just going to be another tool that's going to either get used incorrectly or actually create more issues down the road. The second point there is one that I'd really like to talk about for a second. A strong desire to automate the infrastructure. As we progressed, the company I work for is PennyMac. As we progressed through our usage of Chef, we've actually run into a lot of situations where you really have to have the desire to do that. Because there will be a number of situations when you'll say to yourself, do I really need to go into Chef, and do I really need to make this change in Chef, or can I just go to the server real quick and change something quick like I've always done for years? So that's where the true desire to have this completely automated comes into play. You kind of have to get rid of the mindset that you can go work on one server. Unfortunately, that's really tough for a lot of people to swallow. But you kind of have to get rid of that concept altogether. Everything should be automated. Everything that gets to a server should be automated in its path there and how it's applied once it gets there. So laying the groundwork. First thing we need is a good server infrastructure. And this is going to be a logical or a physical location to deploy the VMs. In my company's case, this would be a data center that's fairly low quality and has caused us a number of issues. That data center is actually the reason why I wrote this presentation. It sounds kind of funny, but an outage in a data center, kind of unheard of, right? That's the reason why you pay money there. They actually happened. I lived it. It was not a fun experience at all. Backups. These are very, very key to this particular type of setup. You have to be able to have the data. The data is the most important thing. A lot of people are in the habit of backing up a whole server. Although that can be very helpful in a lot of situations, when you start using Chef and when you really start automating how everything is built in your infrastructure, you can kind of get rid of the concept of backing up the whole server, because I could probably rebuild the server with correct configs faster than we could pull a backup out of an archive tape, or put it onto a drive, or move it from our long-term storage back onto the SAN itself. So 9 times out of 10, it's actually quicker to bring it up off the ground than it is to try and back it up and preserve it. But the data is what's important. Number 3, a software development methodology. I really don't want to get stuck on buzzwords on this one. The term that I'm going to use is continuous deployment, but in the end, it's just a name. It's just a title for what we're trying to do. We want to be able to make changes fast. An automated system to deploy change and quickly apply it. There's a number of projects out there that you can use to manage your infrastructure as code. We'll talk about some of those in just a second. Okay, so talking about point number 1, server infrastructure. When it comes to rebuilding an infrastructure that has gone offline, whether your data center went offline, whether your network link to your data center has gone offline, maybe you host your data center inside of the company. Your link could go down, and now none of your customers can access your site. So in a lot of situations, the cloud can provide a great resource for us in that we can kind of expect it to have 100% uptime, assuming we're using the cloud provider properly. So if you're talking about Amazon EC2, you want to be in multiple data centers, you want to be in multiple zones. There's a lot of strategies to making sure that you can actually see 100% uptime from your cloud provider, but it's difficult. You have to really think about the process before you get started. It's not just about spinning up one VM in Virginia somewhere. 4 weeks of running in EC2 and Glacier for long-term storage have a much more attractive price tag than a hot standby data center. So here what I'm trying to compare is the cloud versus having a traditional approach to having a hot standby backup. A hot standby backup is going to be extremely expensive, including the fact that most of the time it's just sitting there. It's not really doing anything for you at all. Whereas if you're talking about the cloud, when it's sitting there, you're not paying, which is a great part.
So here you are talking of just making the backup in the cloud or actually running the cluster in the cloud?
So the presentation will actually discuss rebuilding the infrastructure into the EC2 cloud. The reason I decided to kind of present it in that way is that I feel that, like I said, if you are leveraging the cloud to the maximum, you can see 100% uptime. So let's say you have a data center that just went down, or maybe you're not even that big. Maybe you only have a couple servers from a single hosted solution, right? And if that goes down, this gives you the ability to rebuild in what I would consider an environment that can see 100% uptime. Continuous deployment. Lots of small deployments versus large deployments. Whenever a developer commits to mainline, it will automatically trigger the process. Okay, this is very, very key here. A developer committing is what's going to trigger the process. We want to really bypass the idea of having to involve people in the process of a deployment. And what I'm referring to here is actually an actual application deployment, but it also applies to the deployment of nodes through Chef as well. And if you take a look at this picture here, this picture, as I looked at it more and more, I found it about a month ago, and I thought it gave me a good representation of how the flow should work in continuous deployment. But the more I looked at this picture, the more I realized I didn't like this method. I like the feedback, but I don't like the fact that a person actually has to take action for the next trigger to be fired. Okay, so although this can kind of give us a little bit of an understanding of how continuous deployment would work, I would not say that this is a perfect model for us to run continuous deployment. But in the end, we have a few basic things that we want to see here. Okay, we want to have automated QA. We want to have some level of user acceptance as well. But this should be automated. Okay, so when we're talking about user acceptance tests, I would think about something like using Selenium to actually QA against the site. Okay, so this is something that we would take a regular user experience, having them click around on the website, do things like that, and automating that user experience. So although here it's labeled as user experience, we can still see that this fits into our model, and that we want to automate everything across the board. And we want to be able to make sure that when the code actually hits the server, that it's going to run, it's going to work well, and it's going to be reliable, with as little human intervention as possible to make that happen. So automation is key to this CD implementation. If the deployment of the systems or services is not consistent, how can we ever really say that the dev or staging environment matched production? Application developers need consistency to produce changes reliably, differences in the environment can lead to unnecessary troubleshooting and a lot of wasted time. I'm sure many of you have had to deal with the experience of dev and staging being out of sync with production in a number of different ways. So now let's talk about an automated system to actually deploy the changes. Complete automation of the software stack. So whether we're talking about something like Nginx, Apache, MySQL, and that's including a master and slaves, anything running on Linux, we can automate using our system. Let's see. A vanilla VM that goes from nothing to being fully configured and serving traffic in less than 15 minutes is valuable in both disaster recovery and also in scalability situations. If you take a company like Netflix into consideration, they use EC2 pretty heavily, and they're actually able to scale on demand because they leverage a tool like Puppet. There's no way that they could spin up 1,000 VMs if you actually had to build each one of those by hand, even if you were using an AMI template. There's just too much configuration that still has to go on. So without a tool like that, it would just be absolutely impossible for Netflix to scale in the way they do. But they've really taken EC2 and they've shown how much you can really do with a tool like that. When the infrastructure exists as code, there's no need for whole system backups. When a vanilla VM can be configured faster than a system can be restored. So that's actually something I already talked about. But this is a very important concept to understand. Why do we want to bother backing up the whole system when we really just need the data? We already have the configuration in a repository, so the actual server config itself is kind of useless to us. We've got it in a better place and we can deploy it a little bit faster than we can normally recover from a backup, or restore from a backup. So there's a lot of infrastructure management tools out there. The one that I will be speaking about today is Opscode Chef. I'm not sure if any of you guys have had a chance to work with any of the other ones. I've actually had a chance to work with CF Engine. I've been working with Puppet for quite a while too, about a year and a half. And since I can remember, I've been writing bash scripts to do some kind of automation for me to do something that I just don't want to go through over and over again. But as I've come to the Chef world, I realized that a lot of things are kind of already configured for you in a way. So let's take a look at the anatomy of Chef itself. So this is one concept I'd like to throw out at first, that if we look down here, at the bottom, you have Chef clients, okay? These are actually your servers. So it's maybe a little bit tricky to understand that concept, but your server runs the Chef client. Because in this system here, it actually is a client. It's taking configuration information, it's pulling it down from your Git repository or your SVN repository, and then it's applying it to the machine that it runs on. So there's a couple pieces involved in Chef here. The primary tool that's going to get used by the engineers is going to be Knife. You can see it's down here at the bottom. So as consumers of the system, if we wanted to actually see what's inside of Chef, if we wanted to make configuration changes, you'd be using one of these tools right here. The Chef does have a web UI. It's actually pretty good. There is a little bit of bugginess in it, but the recent versions have really cut out a lot of the issues that I've seen in the past. I'd be happy to talk about some of the intricacies of where those errors come from in the UI a little bit after the talk, because it's kind of obscure where you run into those errors. So these two products right here, Knife and Chef Server, are going to send their calls into the Chef Server API. Okay. We use RabbitMQ. I'm not sure if any of you are familiar with RabbitMQ. It's a message queuing service. So if we were seeing extreme load, like let's say we have more than 100 nodes and all 100 nodes check in at the exact same time, that's really going to present a problem if we don't have some kind of queuing for all those requests. The back end is handled completely by CouchDB. The searching and indexing is done by Apache Solr. And out here we actually have the servers, but in this case we're going to just refer to them as the Chef clients, because that's the actual utility that they run to update themselves in Chef, is the Chef client. So this is one of the greatest things that I've discovered about Chef, is that this is a concept of when we really are standing on the shoulders of giants. Number one, we already have Linux itself. I think we all deserve, we all should give a huge hand to Linus and the many people that support Linux. But specifically speaking here, I'd like to talk about the Opscode community. It's actually a really good community, and it's a thriving community. When it comes to something like infrastructure management, if it didn't have a thriving community around it, I don't think I'd even be interested in the project, because this is not the kind of thing that one person or even a team of people can handle. You're going to need, potentially thousands of people to really turn this into the great tool that it's become today. This little piece at the bottom right here, the cookbooks, this is your first source that you should go look to if you decide to start using Chef in your infrastructure. If we're talking about a common server build, let's say we're talking about Apache, MySQL, maybe Nginx on the front end. If you're talking about those three services, head to this website. Your work is 99% done for you. They have recipes that will configure those extremely well, especially those three services, MySQL, Apache, and Nginx. And they can be configured on most OSs. I would even say Windows. There is a portion of it that will work on Windows, but we're in a Linux talk, so I'm going to stick primarily to Linux. Most of those, or actually those three recipes, do have the ability to install on FreeBSD, Solaris, and multiple distros of Linux. Because if we think about the concept of Linux, sure, Linux can install packages. That's pretty standard across the board. But if you're talking about comparing, let's say, CentOS to Debian, it's not the same repository system. Although the end result may be similar, there's subtle differences between the two. So if you look here first, whatever service you're trying to configure, I'd strongly suggest looking here first to see if the work has already been done for you, because it's very unlikely that it has. So let's go in a little bit deeper with Knife.
We're plugging now, though, on it won't work out of the box.
Right, it does not work out of the box. It does not work out of the box. And the title of the talk is Rebuilding an Infrastructure in Under an Hour. Originally, when I wanted to start writing this presentation, I was thinking about building an infrastructure in under an hour. But I don't think that's as impressive as recovering from a complete disaster and having your infrastructure back to the state it was in a different area and still being able to serve traffic just like you could in under an hour still. So the other part of that, too, is that there is a great deal of setup time beforehand to make sure that Chef is actually running your infrastructure properly. Okay, so there's some setup time in that you need to make sure that as it deploys applications and services in your system, that it's actually working correctly. And generally, the problems that I've run into have been package names. So let's say if the recipe that I'm working on was primarily designed for Debian and I'm trying to install it on CentOS, the package names may be just slightly different. So instead of being like libvirtd, it may be just something subtly different. Okay. So let's see. We have a few commands here. These are going to be very crucial to us as we rebuild our infrastructure. Okay. The first one here is going to provision a node for us in EC2. And I had a great question at the beginning of or before we actually started the talk. How do you deal with host names, IP addressing, and everything like that? If we were talking about building a VM in your data center, I would say the right approach would probably be to use something like Pixie to actually bring the VM off the ground. But in EC2, you don't have that direct access to the VM as it's coming up off the ground. So in this case, it may be better to just use an AMI that you've already prepared, okay, and allow EC2 to take care of the host name and the IPs for you, okay? Because in this instance here, you're already going to come up with an IP, you're already going to come up with a host name, and although I only listed 2 options here, there's many other options you have when you spin up your node in EC2. So you can set your security group, so you can already log into it. You can really configure it to really meet your needs specifically. The second command we have here is knife bootstrap. Okay, so if we're talking about a fresh install of Debian, and I mean no additional packages, nothing else, but a fresh install, getting OpenSSH working is the first portion of it, and after we get that, then we want to use Chef to bootstrap. Okay, so when I refer to a vanilla VM, that's what I'm talking about. A basic install that has nothing else on it except for OpenSSH server. Okay, that's all we really need to do this. It's just OpenSSH. The next command here is knife node edit. Okay, this is the command line tool that we will use to actually edit the run list of the node itself. So what is a run list in Chef? The run list is what the node will actually install and pull down from the Chef server. Okay. So a run list can contain all kinds of things. It can contain cookbooks, recipes, but primarily when you really start to use Chef right, the concept of roles heavily comes into play. If we're talking about an infrastructure with, let's say, 1,000 servers, although each one of the web servers may be subtly different, the role of a web server is pretty easy to define. It runs Apache, maybe it runs Nginx, maybe it runs whatever web server you're using. And then on the back end, we have things that can be standardized, whether you run Percona, whether you run CouchDB or any other kind of a database, it's still a database role. So it becomes easy to configure at a high level of thinking, okay, this is a web server, this is a database server, this is a load balancer. So the concept of roles is very, very important when you actually get a little bit deeper in Chef. And the last command here is the command that will actually run Chef client on the node itself. Okay? So in this case, what I'm doing is knife SSH, and I pass in the name of Web2. Okay? Knife actually takes, knife SSH takes some pretty cool searching syntax here, in that if I wanted to run the Chef client on all of my web server nodes, I could actually do role web server, and that would actually, it would do a search against Chef. It would identify all the servers that have the web server role, and then individually it would go through and it would run Chef client on each.
Where does it run that search on? Is there a database server somewhere that has all of your...
Yes, CouchDB actually maintains all of the data for Chef. So it's going to contain the details about the roles, the recipes, the cookbooks, and everything like that. And what I'll do at the very end...
What's in the diagram, right? So it's Solar and CouchDB behind it, so yeah.
Okay. What I did want to show you, though, is I actually wanted to show you some of the data that's inside of CouchDB, because you actually get to see the JSON inside of CouchDB, which is pretty cool.
And is CouchDB resilient? Can there be mirror servers, or?
That's a really good question. I'm not sure. I would think, along the lines of most databases, it has some level of replication. But to be honest with you, I'm really not sure on that one. We've actually gotten to roughly about 250 nodes, and when we got to 75 nodes, we found that a single instance of Chef, and by a single instance, all of the services ran on one single box. We were already overwhelming it at 75 VMs. So what we've done is we've actually separated every single one of the services. The web UI lives on its own server. The CouchDB backend lives on its own server. RabbitMQ is its own server. And then Chef Core and the indexer are the only ones that are actually there. So we've gotten to a pretty advanced state, but that will kind of lead to a chicken and an egg problem in the future. I'll get to that in a minute.
But so what loads the server, the chef server, the database? Because the restaurants on the client side.
So let's see here. The data for Chef would actually live inside of CouchDB, and this is going to be all of the configuration settings. This is going to be all of the roles, all of the recipes. Everything that is Chef is actually in CouchDB.
Did I answer your question?
I'm sorry?
Would you use Chef to spin up the ones that you're saying you have?
I'll get to that in just a few seconds.
You know what's awesome for that? There are three 5 nodes. Like, can I say that out loud? You can use that to spin up your chef server.
Host Chef.
Because it's chicken and egg, you can use hosted chef to spin up your you use hosted chef to spin up your chef server.
You can definitely
configure your chef server.
I'm sorry? Yes.
No, the chef server recipe works well.
That's actually a funny joke. Is that you when you're bringing up your first Chef server, you're using Chef to bootstrap Chef. So it's kind of a funny concept, but it actually works very, very well. However, if I can make a suggestion, when it comes down to running Chef, I would strongly suggest running it on Debian. I've run into some problems on CentOS. It's not that it can't be done, but when I attempted to install Chef the first time on Debian, it took me roughly 35 minutes, and this was before I really had a good understanding of Chef. The first time I tried to install it on CentOS, it took me approximately 12 hours. Because a lot of the documentation on the manual build of Chef is not so great. So I had to write a lot of documentation for it, and the manual install steps I have now are going to work on just about any system that can run, Linux binaries. So it actually, I've tried it on FreeBSD and it works, but again, I would say Debian is the distro of choice when you're installing the Chef infrastructure itself. If you choose
Debian based,
yeah, Ubuntu works really well. Ubuntu works very, very well. So what I'd like to do now, before we go any further,
you really do it that as 4 steps and not one line? Just out of curiosity. When you do it?
I would, primarily because you can't really expect lightning fast performance from EC2 all the time. So I would put a little break in there between those. When we actually watch the video right now, you'll probably get a much better understanding of each one of the things that we're going through.
No, but I mean, I just do it as one line. You can do it. Like passing the run list as part of it, and then put no name and all that on the create line.
Right. That actually is so. There's some funny tricks about that, because if you are talking about bootstrapping a whole infrastructure, we're not necessarily talking about just a few VMs that we've already set up as a role. So in rebuilding a whole infrastructure, I would want to bring up just vanilla VMs. I would want to bootstrap all of them, and then I would want to have a human actually say, okay, we're going to set these aside to do this role, or we're going to set these aside to do this role. But again, when you bootstrap, you could still make the same decision then too. So in the end, I would say it is probably a cleaner approach to put your run list right in here now. But part of the other reason why I wanted to do it this way is so that as I run through the video in just a second, you guys can actually see a node when you're editing it with.
No, it totally makes sense from explaining it. I'm just wondering if you really do it that way.
No, I don't. Most of it, so when I actually bootstrap a node, it's a one-liner about this long in 8 font text. So it's I'm really just trying to simplify things here to make it easier to understand if you haven't actually worked with Chef.
5 years later, you'll come back and be like, what the heck was I doing there?
No, it's really simple. The command line argument is really simple. It's just it makes perfect sense for explaining. I was just wondering if you really did it that way when you ran it. But you answered my question.
Can you guys see that okay? So what we're going to watch here is we're actually going to watch a node being bootstrapped. Up here in this corner is the VM running on my Mac, and then here's where I'm actually going to do the work to bootstrap it up. And as you can see, it is much longer than I would normally, than I had in the command over on the other side, or when I displayed.
Can you talk through it as we run?
Yes.
It's hard to see that from the back.
Wow, that really is hard to
It's-
see. Let me try to get that.
It's the downsizing probably.
Yeah.
Have a lower resolution view. Any views here?
About the same. So it's fuzzier.
Okay. Wow, this is really hard to see.
Doing an apt-get update, right?
Yeah. Right now it's basically just bootstrapping the node. Let me. I have the actual output screen.
Yeah, sitting down.
So some basic things that happen in the actual bootstrap itself. Because Chef runs on top of Ruby, the first thing we need to do is we actually need to get Ruby installed in there. The Ruby of choice is going to be through RVM. If you think about the concept of down the road, at some point I need to upgrade the Ruby that runs Chef, which is it can be a very challenge if you don't use something like RVM. Because with RVM you can have multiple versions of Ruby living on the same system, and then you just pass a command like RVM default with a specific version, and now that's the version of Ruby that you're using. So it makes an upgrade of Ruby much more manageable in the future. Yeah, it's in one of the slides. Yeah, it's in one of the slides.
What's this other one called RBENV? Which I had to use recently to try to run off the bus.
I'm not familiar with that one.
It just says that RBM alternative.
Okay, cool. A lot of the same features.
I have no idea. All I know is when I deal with Ruby, I have to go through them because the Ruby that's installed on my Mac does not work with anybody else.
Gotcha. So it was actually really hard to see that video, wasn't it? Did you guys actually were you able to see any of it? Not all of it.
We use our imagination. Downloading, running.
What I can do is I can give you the text that comes from that run.
People use RVM. I thought I just built a custom version.
The bootstrap that comes from Chef actually does not use RVM. That's a suggestion that I'm making to not use the default bootstrap.
But it builds its own,
Because when you build with Ruby, and I've actually, this was kind of a really annoying problem. The bootstrap that I got from Chef, it works fine on Ubuntu, no issues at all. But then I try and run it on a Debian system and it fails, and I look inside of the bootstrap and I see why, that it's trying to pull packages that they exist in Ubuntu, but they don't exist in Debian. So that's why I would say something like RVM kind of cuts the whole package management issue out of the picture. Because if you're installing RVM, it's the same on CentOS, Ubuntu, Debian. It's going to work the same way, so you have a little bit more consistency across the board.
Yes, still need to install native dependencies.
Yeah. Yep. So there's always a little bit of a problem there. Yeah. So I'm going to kind of just scroll down through this. Stop me if you see anything that looks interesting to you, and we'll chat about it. But generally speaking, it updates your repositories first. On Debian, you're going to update the sources list. And actually, no, I'm sorry, it doesn't update sources list. It adds chef.list under sources.d. So it adds a formal entry. It doesn't write to the one. Chef is actually installed via gems, although you can install it through the package system on Debian and Ubuntu. I think there's even a package for it on CentOS or Red Hat. But I would actually suggest installing it through Gems because it's the most current version. It always takes a little bit longer for them to get into the repositories than the Gem. This is just one of the Gems.
What version of Ruby does it use?
Looks like 1.8.
It can use 187. At work, we're using 193 though.
Now it's it was just fully Ruby. Seeing a lot of 302 errors. It's not an error. It's just saying they moved it.
It's a feature.
It was here, but it's not here now.
As well as hidden Easter eggs. You now get a gold star.
Find the package.
That's what we call it Easter.
So what's really the reason why I want to show it is this right here at the end. Run list expands to node. So this node has been bootstrapped. It just completed a successful chef run, but it doesn't have anything at all in the run list. So unfortunately, it's not going to do anything more than that.
Yeah.
Which one is it?
It doesn't. No. It was right down. It was at the bottom. There was no. The node doesn't exist. So we got a 404.
Not load node web app.
It asked for its run list. I was literally saying the server literally said 404. Your run list doesn't exist.
Will they always see this at Bootstrap, but you have no initial run list? Or
No, and this is actually what he was referring to, is that when you do the knife bootstrap command, you can actually pass in an argument and then define the run list right there in the bootstrap. So yeah, if we already knew that this node was going to come off the ground as a web server, then yeah, I would probably just pass in the web server role and just have it keep going in the run itself. I have another video of the actual install of the web server, but I think we're going to run into the same problem. It's just not going to work. Can you guys see that, or is it distorted too much?
I think go back to making it bigger. I think that was one.
But it's gonna be off the screen.
Yeah, it's going to go off the screen.
Off the screen, we could at least read it.
You know, when I'm about to read it. Okay, so the first thing I'm going to do is I'm going to SSH into the server itself, and I'm just going to prove to you that it's not, it does not have packages Apache, HTTP, or PHP installed. And I exit. Now I'm actually going to edit the node itself using knife node edit. And that's the full server name. You do actually want to use fully qualified names in Chef. It's the better approach to use fully qualified names. Don't just use shortened host names. Did you guys see that at all? When I added the run list. Okay, so here you can see the actual output of the node itself, and all I'm really doing is just adding, and even for you guys that are not coders, it's pretty easy to see here that I can work at the command line with Chef. If this is too much for you, the web UI makes life very, very simple when it comes to Chef. You're literally looking at a drag and drop interface. So for me to add this in the web UI, I basically just have to click on the roll, drag it over, and save the node. So this may look, a little bit challenging to some of you that don't like working with command line. I would hope that's nobody here.
Get out.
But just wanted to throw that out there. Okay, so it's taking a moment to save the node. And Chef actually normally performs much faster than this. I'm just running it in a VM with too little RAM on a Mac, where another VM is running with lots of RAM. So that's actually why the performance is a little bit slower than normal. And here I'm actually going to do the Chef client run on the node itself. So I'm going to do a knife SSH name, and then that's actually a search that I'm performing. The search I'm performing is on the name web app 2. I could have passed in the fully qualified name, but because it's going to search anyway, you don't really need to pass it in. And now we're actually going to watch a Chef client run. So the first thing it does is it updates all your cookbooks to make sure that you have the resources that you're going to interact with. Okay, so if I'm doing, let's say, an Apache cookbook, I may have includes for other kinds of cookbooks, like I may want to include the PHP cookbook. Okay, so when Apache loads first, it's already going to start pulling, or actually when Chef runs at first, it's going to pull all the appropriate cookbooks that it needs. It's going to pull Apache, it's going to pull PHP, all that happens at the very beginning. And here is actually, let's install it. This is the PHP portion of the install. It already got through Apache. And this is all pretty straightforward stuff, and I'm sure everybody in here has probably installed Apache and PHP before. But it's a little bit different to see Chef install it without you actually configuring any configuration files. Okay, that's important to note too. I didn't touch any configuration files at all. Okay, this was all done through Chef. I didn't do any manual steps on the server at all. And actually, I did not even log into the server to do this. If you notice that, I ran it through knife and SSH. And let's see here. What I'm doing here is I'm actually logging back into the server. And I'm going to now prove that it has been installed. There we go. If we're running on a Linux platform, should the distro really matter? Perhaps not anymore. There is some additional tweaking required, but installing a package on Debian or CentOS is similar. apt-get install package versus yum install package produces a similar result. There actually are some very distinct differences that I've noticed between a Debian install of a package and a CentOS install of a package. Primarily that on Debian, the service automatically starts as soon as the package is installed, whereas on CentOS, the service does not automatically start. Seems like a non-important or a trivial thing, but in certain situations, especially like ours, or the environment I work in, we cannot allow a service to come online unless it's been properly configured. That's a requirement we have, especially if it's external facing to the internet. We cannot allow that node to come online and serve anything at all unless it's been properly configured. So a very, very important distinction to make between the two distros, Debian and CentOS. But when you're running something like Chef, the service will be online for less than, I would say, 5 seconds. So we were able to meet compliancy by doing it that way and still run on Debian. Here, this is actually where we can talk about a layer of abstraction that Chef adds for us. So if we are running on Debian or CentOS, the cool thing is that in the actual recipe to install Apache, the command is the same. You'll see down below in the second picture there are still some differences between the two distros. Maybe the config file lives in a different location, maybe it's called something different, maybe the init script has different options. So there's other additional things that we would want to set up that's going to be specific to the distro. But the coolest part here is that whether we were on CentOS or Debian, this is going to work for us consistently. So as we really talk about getting deep inside of Chef, there is the need for very distinct boundaries. Even in the best environments, mistakes can be made. Code can be checked directly into Chef using knife without being committed to the repo first. Okay? And this is an important concept. Everything that goes into Chef should also be in Git or whatever repository you're using. Because remember, this will provide us a system that we can lose everything. We can lose all of our hardware, we can lose the internet connection, we can lose everything. As long as we have the data and our repositories, we can rebuild our entire infrastructure. Nothing else matters. So when it comes to committing or uploading things into Chef, there's a couple ways that we can solve the problem. I feel that uploads into Chef should follow the same approach as application deployments. Code is committed to the repo, automatically gets QA'd, and then is uploaded. This is actually something that we struggle with a lot at work. People just using knife to upload something into Chef, and then we check in Git, and we're like, wait, why is this out of sync? So this is a very important concept to think about, especially in a large-scale environment, because it's not going to be just one person working in Chef. It could be anywhere from a whole team of people to many teams of people working inside of Chef. So automating the uploads of information or data into Chef, I think should be automated. I don't think anybody should have the right to just use knife to edit something directly inside of Chef, because that's when you can get inconsistencies from Chef in the repository. Next, storing passwords securely. If you look at a pretty standard cookbook from Chef, it would have you set up a password in an attribute. There's no security on it at all. It's a plain text field inside of your web UI. So anybody that could log into the web UI could actually see the password itself. But we have a cool new concept in Chef called encrypted data bags. Okay? A key is created on one machine, and then that key is used to encrypt the information. Now, the information remains encrypted the entire time, even during the run itself. The only time you actually extract the information from the encrypted data bag is with a call. It's get data bag ID or get data bag item. Okay? But if we're talking about using encrypted data bags, there's still some ways that developers can kind of get around this problem. You could actually include something in your Chef recipe that would log the data bag item to the log file itself. Okay? So this is a perfect reason why we want to have code review of everything that goes into Chef. So a mistake isn't made, and also so something like that never happens. Bringing it all together. Communication is obviously key when it comes to something like this. We're dealing with two groups that, generally speaking, didn't really play all that nice together. Application developers and systems people. Systems people want stability, application developers need change, and they want it fast. So communication is incredibly important to this kind of a concept here. So now we laid the logical groundwork and we're ready to start rebuilding our fallen infrastructure. We just need the resources to begin the physical build. Okay, so this is where EC2 really becomes an important part of the build. Okay, we have to be able to, on some level, rely on our cloud provider to have uptime. Even if one coast, like let's say the East Coast, goes out of Amazon, we still have multiple other data centers available to us. So if we're effectively using Amazon, we can kind of consider it 100% uptime. But we have to be careful in how we make that consideration, because it's not 100% accurate. Over the past year, Amazon has had a few outages. The worst one I remember was about a year and a half ago, maybe 2 years ago, when the entire EBS store went down for like 3 days. So pretty much nothing in Amazon could run for about 3 days, which was pretty hard for most businesses to take.
It was 3 days. If you very specifically lost data, like,
It was
like 3 hours for me, but like
we actually saw it for 3 full days.
yeah, you got screwed. You had bad, like you were on the bad discs, but
Yes.
like on the bad stores, but like it was only like 3 hours for me. So
The lesson that I learned from that one, big time, was don't just use one data center when it comes to Amazon. Don't just use one availability zone when it comes to Amazon.
and remember, EDS is not guaranteed to exist.
Exactly.
They said that from the beginning. Like
Right.
it's not like everyone treated it like it was invincible.
Right. And we found it is not. So as we begin to rebuild the infrastructure, we need to go about this in a very organized fashion. So the first thing we need to do is we actually need to deploy what I consider the crucial VMs. This is going to be the repository, and this is actually going to be the chef servers. So we'll talk about the concept we were talking about earlier for just a second. If I have, let's say, 5 servers that run my chef infrastructure, a chef core server, a CouchDB backend, a RabbitMQ server, a web server. If I have 4 servers that run that chef infrastructure, how do I bring those 4 servers off the ground if chef hasn't actually come up yet? Okay, so this is where the chicken and egg problem happens. The easiest approach to deal with this particular problem here is by using Chef Solar to bootstrap a node. So this is when we actually get into the concept of Chef bootstrapping itself. It's kind of weird, but in the end it works out and it works very, very well. So what we'd want to do is we would want to spin up one node that would run all of the Chef services on one box. And we don't really need to worry about load on this particular server because that server is really only going to bring up a few nodes. It's going to bring up Git, it's going to bring up our primary Chef server, and any of the resources that we have behind it, CouchDB, RabbitMQ, everything like that. So after we finish deploying the crucial VMs, now is when we want to start bootstrapping all of the vanilla VMs itself. Okay, so in an organized rebuild, we would have people handling very distinctly different roles. You'd want to have at least a couple people actually deploying the VMs. So if you're deploying into a new data center and using vSphere, it's going to be a little bit more challenging than if you're trying to use 9th and EC2, because you can do it so much faster and it's a little bit easier to deploy the nodes. There are several approaches to using the VMware API, so you could actually automate that a little bit. I would say that it's not nearly as robust as EC2 is at this point when it comes to deploying VMs.
Well, I use it. But there's a plugin. There's a
The knife plugin.
There's a knife plugin for VMware, and it works. I mean, whoever wrote it wasn't thinking it through, but
that's actually been some of the stuff that I've found that has come from Chef.
no, but because the guy who wrote the plugin assumed you were going to upload the image you want to
in that same moment
from the machine that you're running knife from, and why wouldn't I just have
in the data store?
Have it in the data store already.
Yeah. and that's actually kind of one of the funner arguments to make between Puppet and Chef is that if you can put real code in the recipe itself, it lends itself to a lot of flexibility. But as we all know, different people develop in different ways. So that can also create complexity too. If you're talking about on the Puppet side of things, it's only the Puppet syntax. So once you learn the Puppet syntax, you're good to go and you're solid. Whereas on the Chef side of the house, you could have some very advanced Ruby inside of a Chef recipe that, without having a real Ruby programmer there, you may not understand at all. So there's kind of a give and take there. Do you want a system that can do anything and everything, or do you want simple, quick, fast? So a bit of a trade-off to make there. So now, this is actually when we want to think about how the nodes are going to play a role in the organization itself. If we just spun up 1,000 VMs, how many of these are going to become web servers? How many of them are going to become SQL servers, a load balancer in front, slaves on the back end that we want to replicate out the master's data? So this is when a plan long ahead of time is going to help us here, okay? Because we really need to know, number one, how many VMs do we really need to bring up? We don't want to bring up more than we need because it's just going to take extra time and it could delay the process. What are those VMs going to do once they come up off the ground? Okay? So a few very basic questions, but questions that we still want to ask long before a disaster recovery event happens.
And yet.
So what I'm actually showing here are a couple different commands, and this is what I was talking about before. As opposed to just running knife SSH on that one node that I spun up, why not run knife SSH on all of the web servers? Okay. So we have a couple different options here. And this is actually one of my favorite ones. This is a catch-all. So it's a wildcard for the name. This would run Chef Client on anything left over that didn't actually have a role. Okay. These would be for edge cases. Let's say you have a server that you can't really define a role for it. There's a lot of different servers, I would say, that could fit into that type of role. Like maybe just a server that does half indexing and then also serves a portion of the web UI or something like that. So there's some situations where we obviously want to be able to deal with the edge cases, because that in IT that's kind of in my opinion, that's the difference between a very well buttoned up infrastructure and an infrastructure that has some loose ends, whether we're really catching all the details.
Why would you use a wildcard name instead of defining a new catch-all role?
Well, like I said, this would be for nodes that just didn't have any role at all.
Yeah. But in designing your system, wouldn't it be better to create a role for those nodes that don't fit in another role?
Yes, it would be. But you probably want to go a little bit deeper in the... So when you're talking about setting up the role should really well define what the server does. So it's super, super difficult to define a role for edge cases. What we actually do instead of defining a full role is we have what we call a base cookbook. So it configures the system to a base level. This would install, let's say, network authentication. So if we're doing LDAP, we would do that. We actually use Active Directory, so we have an Active Directory module that we install. We configure log rotate. We configure SSH to our preferred settings. We can bring in SSH keys. We can do a bunch of cool stuff like that. So it's really kind of just taking it from a vanilla VM to that nice VM that we would prefer to work with.
Do you use UniR2 or what?
I'm sorry?
What do you use for LDAP?
We actually run an Active Directory module. We don't run all that. And then obviously the last step is going to be automated QA. This is going to be one of the most important steps in the process. Can we actually, in an automated way, say this server is ready to work and it's going to serve traffic properly? So QA is, in my opinion, one of the most important aspects of this type of disaster recovery. And the QA needed to have been set up and done long before the event happens, because this is certainly not the time to be trying to QA, especially, if we're talking about 3 or 4 nodes, it's no big deal. A few people can QA that in maybe less than an hour. But if we're talking about 1,000 nodes, it becomes beyond the abilities of even a small team of people to quickly QA that many things. So automation is really, really key in staying under that window of 1 hour to rebuild your infrastructure. And the final event, when we're actually ready to do the final cutover. So there's a couple tricks that we can play to actually make this happen a little bit faster. Instead of editing the run list of all nodes individually, we could simply add the run list to all nodes once they have been bootstrapped and are active in Chef. So let me explain what I mean here. If we were bringing up a server called WebApp2 and this lived in your data center, we already had a run list for it. We already had data prepared that made that node do whatever it is we need. Okay. So if we just took that and applied it to whatever the new name is, we're already set up, ready to go. So it's a one-for-one match there. Okay, you really wouldn't have to do much work aside from running chef client to make sure that that node itself would be identical in both spaces. The order of the operation is really, really going to matter here. A lot of web applications that I've worked with in the past will just completely throw up. They won't even start if they can't reach their backend database. That's very critical for a lot of applications. Some can deal with the errors, but others are not able to. So depending on your web applications, depending on what kind of traffic you serve, order of operation is really going to matter for you. In our case, we bring up the SQL masters first. We bring up slaves next, and then we start bringing up the load balancers. And only after all the rest of the infrastructure is up and ready do we actually start bringing up web application servers. Because we want to make sure that the first time it comes up, it's got all the resources it needs. So after an event like this happens, we, as PennyMac, have really begun to question whether moving to the cloud permanently is going to be a viable option for us. Because we're a mortgage company, we have to deal with a lot of compliance issues. That's the biggest thing holding us back from EC2 right now, is compliancy. Many would argue that security is not actually compliancy. So I can make a node extremely secure that may fail a compliancy audit for one reason or another that's not necessarily all that important. So there's definitely some give and take there. When it comes to actually making the final cutover, let's say you're hosting your DNS at maybe a third-party provider. Okay, you have to take your TTL into consideration here. How fast can you really expect this to happen? If you have a very long TTL, good luck. And what about the many ISPs out there that are also going to cache those DNS entries? Okay, so if you have customers out in the middle of nowhere and you have a bad ISP, you may not see that get updated for as much as 3, 4, 5, 6 days. The worst I've ever seen was actually 12 days, which is pretty terrible. But it all ended up being a caching issue at an ISP. Our DNS entries changed in, I want to say, about 8 hours across the entire internet. But we just had a few ISPs out there that were caching it for just way too long. So we've even seen some issues with that.
I had one that cached. Yeah, they cached negative results for like days. Like that doesn't exist. I'm going to cache that for days.
I'm not going to let you try it. So this actually brings up an important point. When we're doing our load balancing, does it make sense to do it from Amazon already? If our customer's entry point to our web application is in Amazon already, before we ever even had any kind of a disaster happen, we can make this cutover lightning fast. We're talking about seconds versus potentially waiting hours for DNS or even days. Okay, so this is a situation when you really have to question, how do you want to use the cloud if you do decide to use it permanently, and what's an appropriate use of the cloud. Even in our case, we've actually still seen some hesitance from our directors that even just running a load balancer in the cloud may not allow us to pass compliancy for some reason. So it's been a struggle there, but it's something that we just have to deal with. So most cloud providers do have multiple data centers, whether we're talking about Amazon, Rackspace, but even somebody like Amazon is going to see some downtime. Okay, whether it's just EBS, maybe it's just one availability zone on the East Coast. You really, when you start talking about using Amazon, you really have to use it to the maximum. You can't just put, your new infrastructure in one availability zone on one coast, because the odds of that going down or you having at least a few issues are very, very high because it's all in one place. So again, we want to try and use Amazon effectively, so spread out, use multiple data centers. And if in this case we're using the Amazon load balancer, it's it's trivial to send it to one data center or another. It's not complicated at all. So here's some references I have for you. Amazon AWS, very, very key to this type of disaster recovery. You could also use Rackspace too, but as far as I know, the Knife plugin does not have the same functionality that it has with EC2. When I looked into it superficially, it seemed as though you could bootstrap a node in Rackspace, but you didn't have all the options to like pass in an AMI and pass in your key and set up your security zone and stuff like that, as far as I saw. And Optical Chef, here's a few resources. They do have it on GitHub, so you can search for all of the cookbooks on GitHub. I would actually suggest going to the community page first. It offers a little bit more information on all of the packages and the differences between them, because you will actually find some duplicates in there. For instance, there's a MySQL cookbook that will install MySQL Community as well as Percona, but there's also a Percona cookbook that will only do Percona itself. The MySQL cookbook is far more advanced than the Percona cookbook. But that's about it. Any questions?
How do you rehearse for something like this? Do you actually go out and run all the nodes and die?
That's a good question. What we have actually done is we had a lot of old hardware that we were able to repurpose into what we would call like a makeshift test environment. So we've got, let's say like 5 old Dell 1950s or something like that. So we used CloudStack to replicate kind of the same thing that EC2 would do for us. So we spun up nodes there, and we felt that this is, for the most part, a valid test case in that when you're spinning up nodes in Amazon, it can really kind of be, the performance can really go up and down a lot of times. Some nodes will spin up lightning fast. Others are going to take a few minutes to come up. So as we were bootstrapping nodes, we were kind of seeing similar performance that we were seeing in Amazon when we were actually bringing up nodes. So for us, it worked out to be a fairly good test case. But in the end, you would definitely want to try this long before the disaster recovery event. My opinion is that you should actually use this so that you can start doing maintenance during the day. If you're able to deploy a portion of your infrastructure into EC2, you could do maintenance on your normal infrastructure while just sending the traffic up to EC2. So this could actually provide you a way of testing your disaster recovery scenarios consistently. Every time you need to do maintenance, every time you need to do an upgrade, send it to EC2. Let's make sure everything is still working right.
Yeah, that's hard to do without an outage on a production system. We had a 6 megawatt UPS maintenance we had to do. So we actually failed over from a data center on the West Coast to a data center on the East Coast. That was months of planning. It was not trivial. But now we know if something goes down, we can do it.
Right. And to, so we all finished? Because I actually want to turn it off to tell this part of the story. So we, the event that actually caused this to happen.
Everyone's cameras on?